In this video, we're going to look at the 6 different types of simple machines. We're going to look at what they are and how they help us with our work. All right, so what are simple machines? Simple machines are machines that are going to have few to no moving parts, and we're going to use them to make our work easier. So remember, when I say work, I'm talking about that thing that we talked about in the last video, which is basically how much force is exerted over a distance of time, and that's going to be the amount of work that was required. So, moving on. A wheel and axle is going to be our first one that we're going to look at, and that is where an axle, which is the rod that goes through the wheel, is going to allow that wheel to turn. Okay, we see this on how most of us got to school. If you rode a car, if you rode a bus, if you rode a bicycle, all of those use a wheel and axle. So you exert a force, and then the wheel is going to turn while on that axle. Another example are gears. Gears are a form of a wheel and axle as well. So we're going to move to our next, which is our pulleys. And pulleys are basically a wheel and axle with a groove around the outside. And then it's also going to have a rope or a chain or a belt that's going to be around the wheel that's going to allow that work to become easier. We see example here with this gentleman who is pulling up a load up higher, and then we have up here a construction crew that is using a pulley to move construction material. So there are different types of pulleys, however, and they all use force in a different way. So our 3 different types of pulleys are a fixed pulley, and a fixed pulley is going to be attached to something stationary above it. And it is actually not going to make the amount of force needed any less, but it is going to change the direction of the force. So basically, I'm going to pull down on the rope and the object's going to go up. An example of this would be a flagpole. And something that's good with a fixed pulley is that we can use the effect of gravity and our body weight to help pull that rope down. Next, we have a movable pulley, and a movable pulley is just as its name says, is movable, so it's going to move, and it is going to increase the amount of force applied. So it's going to increase, if you apply force, it's going to increase that, but it does not change the direction of the force. So if I pull the rope up, the object is going to move up. And an example of this would be a well. So if you've ever seen people draw water out of a well, you pull up, the basket comes up with the water. Last but not least, we have a block and tackle pulley, and this is basically just a combination of a fixed pulley and a movable pulley. The more that you have, the more pieces of this pulley you have, the easier the work is going to be. Next up, we've got inclined planes. And inclined planes are flat surfaces that have a higher end and a lower end. And I want you to think of a ramp. A ramp is a really good example of an inclined plane in its simplest form. And it spreads the force needed over a longer distance, which makes our work a little bit easier. So we can see here we have a ramp. Slides are also an example of an inclined plane. So when these 2 inclined planes join together back to back, they create a wedge. And the most popular example of a wedge is an axe. So we bring the axe down, it's going to split that wood, it's going to change the direction of the force. Some other popular examples are a knife, a flathead screwdriver, a zipper, and a shovel. This is also a nail. That would be an example of a wedge as well. So when that inclined plane wraps around a cylinder, then we call it a screw. And the screw with that inclined plane wrapped around it is going to be able to move when it's rotated. So we think of when we rotate that screw, it's able to move down into an object or up out of an object. So obviously a screw is a type of a screw. But also we have bottle caps, and those are also an example of a screw as well. So think about when you unscrew that water cap when you're about to take a sip, you're moving it up that inclined plane, taking it off, and then you might screw it back on. So next up we have levers, and levers are Basically, we see them all the time in our life, but we might not think of them as a lever. But there's going to be three different types. There's going to be first class, second class, and third class. So first up, we have first class levers, and this is when the fulcrum, which is a point at which is being supported or where the object is going to pivot from, is going to be in the middle of the load, and the effort is going to be applied on either side of the fulcrum. And the best example of this would be thinking of a seesaw. Our second class levers, the fulcrum is at the end of the lever and the load is in the middle. For an example of this would be a wheelbarrow. And our third class levers, the fulcrum is again at the end of the lever, but the effort is in the middle this time, or the force being applied. So an example would be tweezers, right? We apply the force in the center of the tweezers, and the fulcrum is at the end. The part where they're attached is at the end. Some other common third class levers, a broom, tongs, or even going fishing. A fishing rod would be an example of a third class lever. So how in the world are we ever going to remember all the different types of levers? Well, I've got a little song for you. FLE, 1, 2, 3, FLE, 1, 2, 3. I know, that's so silly, but it's going to help you remember that a first class lever has the fulcrum in the middle, a second class lever has the load in the middle, and a third class lever has the effort or the force applied in the middle. So anytime you're trying to remember, is it a first class, second class, or third class level, think FLE, 1, 2, 3. So simple machines basically just make our work easier for us by either changing the direction of the force or easing up the amount of force needed to go a distance. And when we combine all of these simple machines, we can make a complex machine, much like this bicycle shown below.